everyone. Just going to give it another minute before we kick off here. Thanks for coming today. Alrighty, let's get started. Thanks everyone for coming today. We're going to discuss Red Hat AI Inference on CoreWeave. So we've had a big announcement of how Red Hat and CoreWeave are working together to develop inference solutions for enterprise, and we're going to talk through some of those different open source collaborations that we've had over the course of the past couple of years, and up to some of the products that both companies are building. I'm joined by Urvashi from CoreWeave. Do you want to introduce yourself briefly before I introduce myself?
Absolutely. Hello, everyone. Thank you for tuning in. I'm Urvashi Chowdhary, and I lead the AI training and inference product management team at CoreWeave. Prior to CoreWeave, I spent over a decade at Amazon as a product leader on AWS flagship AI/ML platforms and services. One of the things that I enjoy most is working with customers across leading AI labs, enterprises, and startups, and help them accelerate their innovation on CoreWeave. I've had the honor of partnering closely with the Red Hat team over the last year and on various initiatives, and I'm really excited to share more in our conversation today.
Thank you for joining me. And for those I haven't met, I'm Rob Shaw from Red Hat. I'm a member of the technical staff focused on our inference projects. So I joined Red Hat about a year and a half ago by way of acquisition of a company called Neural Magic, which was focused on inference open source software in the VLM community. I'm one of the co-leads of the VLM project and one of the co-leads of the llm-d project, and spend all my time working on making inference as fast as possible and trying to make customers successful using these technologies. So I also share a passion for building production quality inference systems, and it's been great partnering with CoreWeave over the course of the past year, and we're really excited to share a bit more about what we've been working on. So let's dive in.
Sounds good. And Rob, let's start with the basics. Why don't you tell us what inference is?
Yeah, of course. Before we dive into all the fun stuff we've been doing to optimize it, it's always useful to just take a step back and think about, what problem we're really solving here. And inference is really a critical part of any AI application. And inference is really the process by which that abstract model, that huge binary blob that gets created and gets trained on the huge clusters that we have on places like CoreWeave. Inference is really when that model turns into something useful. So if you're an AI user or an AI agent that's interacting with a model, inference is really the process by which that model takes a prompt and turns that prompt back into a response. And so there's really three layers of the inference stack. There's the models themselves, and of course, there's the hardware accelerators upon which the model runs. But in between that, there's a piece of inference software, a stack, which is responsible for serving that model and scaling that model over many GPUs to make things as efficient as possible. And so inference is really this process by which we turn the model and the hardware accelerator into an endpoint that a user or an agent can call and get back a response. And so do you want to talk a little bit about why inference matters, like what role it plays for companies trying to build AI-powered applications?
Absolutely. So inference is the defining layer in AI. As Rob called out, it's where models are actually put to work and performance in production starts to show up. Enterprise inference is not a one-time deployment event. We should think of it as a continuously operated production service where there are a few factors that are top of mind and critical. These are latency, availability, and cost behaviors. We need to manage these under live demand. At the same time, for enterprises, it's paramount to maintain visibility into the inference stack, to be able to support security and compliance requirements, as well as make sure that inference workloads can scale so that they can reliably run inference in production. One of the key trends that is shaping how enterprises also think about inference is the rise of AI agents. So what was once just a real-time chat application is now a always-on production requirement. We need to think about agent-driven workflows from customer support to software development and internal operations. And all of these rely on fast and scalable inference. At the same time, as the workloads multiply across enterprises, the demands on the infrastructure that supports them also increase. So while Kubernetes transformed how the industry deploys and manages software, inference workloads are slightly different, and they place new demands on our infrastructure as well as the serving stack that the conventional container orchestration systems aren't really designed to scale. So let's spend a little bit of time on what is really different with inference. So inference at scale is different from cloud workloads because it's stateful, it's hardware sensitive, and it can quickly become costly if we don't manage the setup well. So the key things that impact the performance and cost characteristics can vary depending on the type of model that is being deployed, the infrastructure behind the model, and then the serving stack itself, and of course, the request patterns. So one of the things we're seeing is model sizes range from few billion parameters to trillions of parameters, which require different deployment infrastructure. So you need to serve these models in distributed ways so that these are spread across multiple GPUs. So that's complex to manage. At the same time, the token usage across requests may also not be consistent. So if you think about chat applications versus agentic applications could consume 5 to 30 to hundreds and thousands in the case of coding applications, higher token volume than just your typical chat applications. And then as you add tools and sub-agent orchestration, the token usage can vary along with the demand patterns that you might see. So all in all, you need to manage the different model sizes, the prompt length, the cache locality, and you have to manage models that are either compute bound in the prefill phase or memory bound in the decode phase. So typical cloud deployment applications are not able to sustain the demands for production inference, which is why we need to think about it a little bit differently. One of the key trends that we're seeing is that enterprises are increasingly looking at open source models, open source frameworks and tools that give them more control over their inference deployments. This helps them manage security needs, cost profiles, and optimize performance across different layers. Rob, I'd love for you to share a little bit more about how the open source ecosystem has evolved and some of the amazing work that the Red Hat team is doing along with the community in this space.
Yeah, absolutely. This is one of my favorite topics, and this is a slide I've been working on for actually 3 years now, as I've been following the open source space. But if you just think back to it's crazy that it's only been this long, but if you just think back to November of 2022 when ChatGPT first launched, it was so clear that generative AI was going to be a transformative technology. It's one of the fastest ramps of any product. But at the time, open source models basically didn't exist. There was things like OPT, from Facebook at the time that, was a open source recreation of, GPT-3, but the gap between where the frontier models were and where open source models were was just incredibly, incredibly wide. And honestly, like as someone who was building infrastructure software for open source models, it was a little bit of a scary time because there really wasn't an open source ecosystem. But what we've seen over the course of the past 3.5 years now is just an absolute explosion in the open source ecosystem. Starting in 2023 with the first open source models, Mosaic MTP, Together AI's Red Pajama for people who have been following for a long time and remember that. These were kind of like the first open source models that got the ecosystem kicked off. And then in 2024, we had the Llama 3 moment where Meta released the Llama models, the Llama 3 models, which were really the first kind of economically useful open source models that set off just this huge ecosystem, of capability, quality, and really having good architectures that could solve actual, business tasks. In 2025, we had the DeepSeek moment, R1 with the reasoning models. NVIDIA's entered the scene with their Nematron series. Google's been on the scene with, the Gemma series. And of course, the explosion of architectures bringing in this reasoning model capability with the mixture of experts architecture. And then, of course, into 2026 with all of the agentic frameworks like OpenClaw and OpenCode and models building this agentic capability with tool calling into them. And these open source models are just simply getting better and better and better and better on a week by week basis, with simultaneous 100x increases in model size, context length, and workload level token consumption, as we shift from these single turn deployments to these highly complex agent deployments. And so, as was mentioned, open source models are becoming a key part of every enterprise architecture. I still think frontier models will play a key role for the foreseeable future, but folks are really starting to deploy open source models to really control their costs, control the security, control the life cycling, in addition to deploying these frontier models. And this capability is really showing, no signs of slowing down. And so about a year ago, so over the course of the past few years at Red Hat, we've been working in the VLLM community to build that open source inference serving runtime alongside, many partners in the ecosystem. But really, as we looked at the space, at the beginning last year, we really saw an opportunity to invest in the next frontier of optimization. So, while VLLM looks at optimizing a single node, implementing performance optimizations that can squeeze as many tokens as possible out of each, node, there was a big gap in the market for a community-driven open source project to tackle, inference at scale. And implementing these performance optimizations, such as disaggregated serving or prefix cache-aware routing or multi-node YDP, all of these really fun, distributed optimizations that can, squeeze more and more and more tokens out of a whole cluster. We created the llm-d project as a community open source project to, really tackle these projects. And CoreWeave has been a huge supporter and contributor to the project since the initial launch last year at Red Hat Summit. Contributing, actual code and also lots of hardware resources, for us to be able to develop these YDP, PD disaggregation, cluster scale features that are needed. And so it's been a great, collaboration in the open source to really build this community. And to just give a flavor of the type of optimization that I'm talking about, that llm-d brings on top of the LLM, we can take an example of something like prefix cache-aware routing. If you think about an agentic application, these are multi-turn in nature. The basic architecture of an agent is that it will run in a loop and oscillate between reasoning through the model, calling tools, reasoning, calling tools, making a plan, and so on and so forth. And so for every one kind of user session, there ends up being actually multiple inference requests to the model, which share the same prefix effectively, because we're just appending context to the model each one of these turns. And so an absolutely crucial performance optimization is that VLM can keep track of these KV cache states and effectively skip recomputing that prefill phase for the already cached prompt if we do proper routing. And so, to the point about Kubernetes needing to evolve its networking layer, if you just deploy a standard service in front of a standard deployment, you're going to get round robin load balancing and have a 1/n chance of getting a cache hit with kind of naive Kubernetes networking. And so what llm-d does is we can inject that LLM aware logic into the Kubernetes networking stack. So, we'll have like an Envoy proxy. It calls out to the endpoint picker. This endpoint picker can be aware of the cache affinity. It can be aware of the load state, and it can make smarter decisions about which pod the request should route to, taking into account that we're running these multi-turn workloads. So this is like a bread and butter, absolutely crucial optimization that kind of sits at the core of llm-d. Another example is, as was mentioned, we have the prefill and decode phase of inference, which one is compute bound and one is memory bound. And so there's lots of optimizations that can be applied by independently optimizing for those two phases of inference. And so one of these is called disaggregated serving, where we run prefill on one node, decode on a different node, and independently optimize those two phases of inference. This requires multi-step inference pipelines with orchestration. You want to compose that with things like prefix cache aware routing. And so the overall llm-d system can enable the orchestration of these more complicated, inference pipelines. So I don't mean to give an exhaustive list of all the different optimizations that we have in llm-d, but just to give a flavor of where the project sits in the overall inference stack, it's implementing these kind of distributed optimizations that can help improve performance as you really scale out your deployment. And llm-d, the community has been going really great. We launched the project a little over a year ago. And since then, the community has grown very, very well. And we recently joined the CNCF as a sandbox project. And we're continuing to invest really, really heavily in pushing the project forward. And so please take a look at our new doc site that I sweated over for the 0.7 release and to see the updates on what we've been doing in the open source. But before we dive any further, do you want to talk a little bit about CoreWeave's cloud and the different capabilities that you're bringing before we dive back into what we do together?
Absolutely. And I want to say huge thanks and kudos to you and your team for all of the amazing work on llm-d and the project and the community engagement. I think one of the things that got us so excited about llm-d was the promise of solving Kubernetes-native, production-grade distributed inference that really empowers teams and our customers to be able to build state-of-the-art inference solutions and be able to do it effectively and leverage some of the optimizations that CoreWeave Cloud as an AI-first cloud offers. So I'll quickly walk through the CoreWeave Cloud and how, particularly for AI inference workloads, we've really optimized the end-to-end stack to deliver the best performance for AI inference workloads. So if we start from the bottom left and make our way around the top, the foundational infrastructure is our purpose-built data centers and infra that really maximize performance for the leading GPU accelerators that deliver high-speed interconnects and are able to deliver the best performance for large-scale AI inference and training. So we're consistently the first to bring the next generation hardware to market, from the Hopper series to Blackwell, and will be among the first on the Vera Rubin deployments. One of the places where we've partnered closely with the IBM team is bringing the GB200 NVL72 cluster out when first in the market, and continuing to enable customers to scale with the latest hardware so that they can stay at the bleeding edge. We're really excited that CoreWeave is NVIDIA Exemplar Cloud certified for AI training and inference on the GB200 NVL72 system, and that we delivered leading inference performance in the latest MLPerf inference on the GB200 and the GB300 system for DeepSeek R1, which is one of the frontier reasoning models. So really the foundational infrastructure and the platform that we offer is designed for customers to take the latest models and realize the value from them. Now, moving up the stack, for AI inference workloads and training workloads, high-speed data access and storage is critical. So the CoreWeave AI object storage with its local object cache delivers really high performance, and in the context of inference, enables fast model checkpoints and image loading, KV cache transfers. So, as we get to the memory-bound prefill decode stages, managing KV cache is important, and so leveraging the local acceleration on our AI object storage gives that additional performance advantage. Building up from that, our infrastructure control. So this is the CoreWeave Kubernetes Service. It's Kubernetes-native. You bring your current tooling without any additional proprietary setup, and we delivered bare metal performance with deep security controls and end-to-end visibility across the hardware and the cluster. We're also make it super easy for customers to run AI training and inference workloads with Sunk, which is the Slurm on Kubernetes offering that we have. And it enables customers to do mixed use scheduling for training and inference workloads across large scale clusters and see higher cluster utilization, higher goodbud, and effective training times. And on the model and agent development side, we offer our various inference solutions, from serverless inference to dedicated inference to enabling self-deploy options on CKS, and enable customers to have end-to-end visibility and tracking across model training and inference with the weights and biases products like weights and biases models and Weave, which customers use and standardize as their operating standard for AI workloads. And then mission control is CoreWeave's backbone and foundational pillar that drives deep observability, security, end-to-end performance visibility for customers, so that when you are deploying large-scale inference workloads and training workloads, you have automated health checks and remediation to keep your cluster performance high and to deliver the full visibility from model to metal for your workloads. And one of the key parts about CoreWeave that is my personal favorite is our operating model and engagement with customers. We partner very heavily with customers on providing direct-to-expert support, working as part of their extended teams, and helping them achieve state-of-the-art performance for their workloads. So we can move to the next slide. I think one of the parts that I wanted to focus a little bit on are the partnership milestones and why we think these are so exciting for customers and the community at large. So we believe open source software is essential in driving innovation in AI/ML space, and then also in offering flexibility to developers. We've built our AI cloud platform from the ground up on Kubernetes, and we're really excited that we get to partner with IBM and Red Hat team on accelerating inference. So starting with the work that we did with IBM to bring up the largest GB200 NVL72 system that was used to train the state-of-the-art Granite models, and also used for achieving the MLPerf results on training. We leverage a lot of those learnings to apply as we build the partnership on llm-d, We were thrilled to be one of the founding members and contributors to llm-d, and to continue to deepen our commitment to open source systems. We're very excited as llm-d moved to CNCF. And then over the course, one thing that we learned from our customers is that customers have an increasing need for us to support hybrid deployments. And running inference in hybrid deployments, which is on premises and in the cloud, is a challenge for many enterprise teams. They need to do this because they have security requirements, data residency requirements, or regulatory requirements. But this also adds a lot of complexity and operational toil. So you need to maintain separate stacks, one for your on-prem systems and one for your cloud system. You have to maintain tooling and expertise across the two. And then you also have to keep pace with the rapidly evolving landscape right now, with new model architectures, new optimizations coming in. And so we found that teams need a way to achieve consistency, but then also have speed and leverage the cloud as well as their on-prem deployments. So this is where we were really excited to partner with the Red Hat team on the Red Hat AI Inference deployment blueprint on CoreWeave Kubernetes Service, or CKS. This really brings the best of the two worlds together. So if you're building an inference stack from the ground up, it can be complicated. You need to build model gateways, you need to manage your distributed frameworks, inference engines, and then manage the underlying clusters. And Rob talked about some of the complexities there already. And so we're really excited that we can leverage Red Hat AI Inference on CoreWeave so customers don't have to build the entire stack from scratch if they're self-deploying their inference solutions. They can get the benefits of CoreWeave's AI-first, performance-driven cloud, take advantage of the full performance as well as the observability and the reliance that we offer on the platform. But then they can continue to deploy their own inference stack and manage the same stack on premises as well as on the cloud. So we're super excited about this. And Rob, I think this is a good time to dive a little bit deeper into the Red Hat AI Inference solution.
Yeah, thank you. And I'm also very excited about this. So, and I totally agree with, this hybrid, environment, especially for the largest enterprises. We're seeing GPUs on premises, we're seeing GPUs in the cloud. And so we've really tried to assemble the set of software that's really needed to build that, high performance inference. But I think really importantly, there's more than just that high performance inference that's needed to run a production system. So obviously it needs to be performant. We need to be able to squeeze, the most possible tokens per second out of every GPU and implement all the key performance optimizations on the latest accelerators and every single model optimization you can think of. All that stuff needs to be supported in the stack, and achieving that state-of-the-art performance is absolutely crucial for making AI economical and achieving the ROI that you're looking for with your AI deployments. But in addition to this, for customers that are building self-managed inference, there is a need for that consistent day two operations to be able to scale this to multiple different environments, multiple different models, manage the life cycle, et cetera, manage who has access to what models, how many tokens should they be able to consume, guardrails, so on and so forth. And so this is really what the Red Hat AI Inference Stack is pulling together, is all the different components that are needed to stand up this high performance inference system that has the consistent day two operations that are needed for SRE teams to be able to have a seamless experience when they manage the stack. So typically when I talk to customers, I think about 4 different layers in the stack. VLM is the core runtime. Its job is to be that Rosetta Stone that maps all the different model architectures onto the key accelerator generations. So Hopper, Ampere, Hopper, NVIDIA Blackwell, GB200, Vera Rubin. We have the same piece of software that's abstracting away that underlying complexity and implementing optimizations for each one of those, generations of hardware. And then, as was mentioned, there's so much innovation in the model space. every single week we're seeing a new architecture come out. They don't want to let us sleep, but yeah, it's crazy. And so, but a platform like VLM, is really important for being able, since VLM works with all the different key model providers. We're able to get that day zero, support for the new architectures, and then quickly optimize for the key performance, the key hardware backends. Then on top of this, we also have the models themselves. There's lots of opportunities to optimize those models directly. So techniques like quantization, if you're running on NVIDIA Blackwell, you want to take advantage of things like NVFP4 to get more and more, the highest number of possible flops out of the machines. It's becoming quite mainstream to implement speculative decoding techniques like Eagle or DFlash, or MTP that's starting to be released with different models. So there's also lots of opportunities to optimize the models themselves, and Red Hat's model catalog provides a secure way for customers to get the models from Red Hat registry through the secure software supply chain, have pre-optimized variants, and then of course leverage our toolkits like LLM compressor and speculators to potentially do additional optimizations on top of any fine-tuned models. We have the distributed inferencing layer. llm-d has obviously been a huge open source partnership between Red Hat and CoreWeave, and others in the ecosystem. That's the distributed inferencing layer that's going to implement all the key distributed performance optimizations like KV cache-aware routing, disaggregated serving, KV offloading, all of the kind of runtime architectures that implement performance optimizations. But very importantly, we pair llm-d with Kserve, which implements very consistent CRDs that automate the deployment of llm-d. So setting up all the Kubernetes networking, dealing with the things like MTLS, pod monitors, all of that deployment automation stuff that's needed to have that consistent day two operations. llm-d and Kserve work together as that kind of layer as you start to scale out the system. And then increasingly, what I've been seeing is the emergence of this AI gateway layer, which is really the API management, layer in the stack, which is going to provide centralized access to both self-managed models and cloud models, such as Claude or Gemini or other proprietary cloud-based models. And the AI gateway is really that central access point where enterprises can control who has access to which model, how many tokens should they be able to consume per month, rate limiting, guardrails, and so on and so forth. That provides that kind of centralized access control. And so all these layers of the stack are needed to stand up a production quality inference system. And this is what we've been building and will continue to build inside of Red Hat AI to build this inference stack that can run, across the hybrid cloud. And so, we're really excited to announce with our 3.4 release, this is in tech preview on CoreWeave Kubernetes Service, the supported stack. We install it via Helm chart with operators to kind of deal with all the life cycling of the different versions, so on and so forth. And this will be GA'd. Our Red Hat support for this stack will be GA'd as part of our 3.5 release later this year. So maybe we can pause to see any questions. I have some architecture slides as well that we could talk through to explain how some of these layers are implemented technically, but maybe we can take a quick pause to see if there's any questions from the audience, and then we can go into more detail if needed. Carlos, do you know if there was any questions from the audience?
Yeah, we have one on when should we use Kubernetes CoreWeave services versus OpenShift AI in a regulated enterprise, for example?
Yeah, sure. That's a great question. So I think this comes back to the overall concept of hybrid, environments. And so a lot of times what I tend to see happen is customers will have GPUs in CoreWeave, and then they'll also have on-premise GPUs, which can be running, OpenShift, for instance. And so OpenShift AI includes the Red Hat AI Inference stack on OpenShift. So all the different layers that I talked about, VLM, llm-d, Kserve, AI Gateway, all of the same software stack that we're running on top of CKS. This is packaged in OpenShift AI, and customers deploy that as an operator. It's a slightly different install pathway on OpenShift since we have Operator Hub, which is the way we ship the operators. So on CoreWeave, there's a Helm chart that installs the operator. On OpenShift, there's Operator Hub that installs the operator. But at the end of the day, it's the same overall software stack that's being run in both environments. So this is really the key piece. OpenShift AI is for folks running OpenShift Kubernetes. Red Hat AI on CKS is for folks who are running CoreWeave Kubernetes Service and want to deploy this inference stack on top. And very often we will see our customers running in more than one environment. And so a big part of the value proposition of the Red Hat AI Inference self-managed stack is to have that kind of consistent deployment operations between the different environments that they're looking at.
Yeah, I would call out the key here is flexibility and then also interoperability, because one of the things we consciously, from CoreWeave standpoint, one of our tenets for building products and services is to enable open interfaces. So while we may offer and we do offer managed services where the full stack is built and managed by us, and customers can consume the latest models either on a token basis through our serverless option, or have more control with the dedicated deploy option, or we still continue to support customers and advocate for customers that want full control of the stack and want to self-manage the deployment. And by giving them the solutions like Red Hat AI Inference, where on their on-prem system deployment on CoreWeave or on other clouds, they have the flexibility to run the same stack and take advantage of the underlying cloud platforms. That's a big win for customers, particularly enterprises that are in those regulated industries and have compliance data residency requirements.
The other piece I think I will also clarify is like what it means for a Red Hat supported stack, like what that means, because at the end of the day, the Red Hat stack is based on all open source, components. So like, it's absolutely true that someone can assemble all of these different pieces and deploy it themselves. And many organizations do that. But what's part of like the Red Hat, capital S support is things like, if something breaks, you have access to the team who has built and like leads the community in all of these different components, who can debug, solve any issue that you're dealing with, and fix the problem. So there's that kind of like production SLAs of response time, and how we're dealing with any sort of issues that might arise in a production environment. And additionally, as part of that, those capital S supported images, if something breaks, these are in place fixes. So, if there's an issue on the particular version that you're running, it doesn't require you to update the entire stack, which can introduce other issues, when that happens. So the software goes through a life cycle where, we support the images in place and make sure that you have stability in your environment, as you're, dealing with things. So that's one part, is like the capital S support is about, the, kind of in place, any issues that occur, the teams are there to be able to help, solve any problems. The second piece is, I just listed out a pretty complicated stack. There's like many different open source projects, which all have their own life cycles, all have their own integrations, to do, if you're deploying llm-d, you have a gateway involved, you have to connect that to llm-d, you have to connect that to VLM, a gateway that sits in front. There's lots of different components. And so a big part of the overall Red Hat stack is there's an organization which is validating all of these things work together, testing that all of these things work together in different environments, providing unified installation pathways for those things, updating them all together. So that kind of productization of the different components is another key, reason why, customers will often work with the Red Hat stack. The next piece is the security and CVEs. So we have SLAs for remediation of different security patches associated with all the different images, throughout the support lifecycle. And so these are some of the key reasons why, customers will, work with Red Hat. It's that kind of production support, people that can help you if things go wrong in your production systems, obviously very critical. It's the integration of all of these different components into a working system that, we test and validate end to end. And then of course, the security life cycling of all the images, building them all from source, distributing them through a secure software supply chain, and remediating CVEs as they come in, are kind of the fundamental pillars that, help to, that are the reasons why people choose to use the Red Hat stack, in a supported fashion on top of, OpenShift or on top of CKS. Any other questions?
For now, I think that's been a very comprehensive session. Thank you so much to our phenomenal leaders covering this amazing session. Yeah. So maybe, I don't know if Rob and Urvashi, you guys want to maybe say one last words?
Well, I will echo what Rob said. Inference and inference deployments are not a one-time event. You have to manage them on an ongoing basis. You have to scale them. Having a solution which is vetted, that is well supported, is critical, and is built on open interfaces, so customers have more control and can manage their, own their own destiny in some cases, with the flexibility of running it across hybrid deployments, whether it's on your own on-prem system on OpenShift or with CoreWeave Cloud. I think this is it's a great enabler, and I'm really excited to partner. Our teams are very excited to partner with Red Hat team on enabling the solution for customers. Thank you.
Absolutely. I totally agree. And these problems are also very fun. So in addition to, wanting to work closely with customers, if folks want to get involved with any of the projects, I know we're hiring at Red Hat. I'm sure CoreWeave is also hiring for, these types of to work on these stacks, because the problems are growing faster than the solutions. So we need to keep working hard. And so yeah, I'm really excited, and it's been a great partnership with CoreWeave and the rest of the open source community, and couldn't be more optimistic about what's to come with open source models running on these really fun hardware accelerators. So thank you all for joining today.